Grazie a voi che avete organizzato questo grande evento e buongiorno a tutte e tutti. Siamo molto onorate di avere qui all'Università di Padova l'esperta mondiale di innovazione di genere, la professoressa Londa Schiebinger. La ringraziamo moltissimo per aver accettato il nostro invito nel contesto degli Open Innovation Days. La introduco brevemente, leggendo il suo curriculum. Londa Schiebinger è professoressa di storia della scienza presso la Stanford University. È direttrice del progetto Gender Innovation Science, Health and Medicine, Engineering and Environment, finanziato dalla Commissione europea e dalla National Science Foundation e dall'Università di Stanford. Ha conseguito il suo dottorato alla Harvard University nel 1984. Dal 2004 al 2010 è stata direttrice del Clayman Institute of Stanford per la ricerca sul genere e componente eletta dell'American Academy of Art and Science. Nel 2010 e poi nel 2014, nell'ambito delle Nazioni Unite, ha presentato il discorso programmatico su Gender, Science and Technology e ha scritto il background paper. Le risoluzioni ONU del marzo 2011 richiedevano esplicitamente che nella scienza e nella tecnologia venisse introdotta l'analisi basata sul genere e che i curricula fossero curati integrando il genere. Ha collaborato con la Commissione europea a numerosissimi progetti. Uno in particolar modo, nel 2013 ha presentato al Parlamento europeo i risultati del progetto Gender Innovation in Science, Health and Medicine, Engineering and Environment. Tale progetto era iniziato nel 2011, quando Londa Schiebinger aveva avviato una collaborazione importante con la Commissione europea per promuovere una ricerca sulle innovazioni di genere in differenti discipline. Era responsabile del gruppo di esperti chiamato Innovation Through Gender, istituito dalla Commissione europea e composto da più di 60 esperti dell'Europa, degli Stati Uniti, del Canada e dell'Asia. Nel 2014 Gender Innovation è stato anche presentato all'Assemblea nazionale sudcoreana e nel 2015 Schiebinger ha coinvolto 600 partecipanti di 40 paesi su Gender Innovation alla conferenza Gender Summit Asia-Pacific. Londa Schiebinger ha ricevuto numerosissimi premi e riconoscimenti, tra cui i prestigiosi premi Alexander von Humboldt e John Simon Guggenheim Fellowship. Ha ricevuto dottorati onorari dalla Libera Università di Bruxelles, in Belgio, dalla Università di Lund, in Svezia, e nel 2018 dall'Università di Valencia, in Spagna. È autrice di moltissime pubblicazioni internazionali e di numerosi libri, tra cui cito Women and Gender in Science and Technology, 2014, Gender Innovations, How Gender Analysis Contributes to Research, As Feminism Changes Science, The Mind Has No Sex, Women in the Origin of Modern Science. L'approccio proposto da Londa Schiebinger per affrontare le questioni di genere nella scienza è quello basato sul concetto di fixing the knowledge. Si tratta di integrare la dimensione di genere nei contenuti della scienza non solo a livello di comunicazione, ma a livello di creazione dell'innovazione. Vorrei far notare che tra i milestone indicati nella strategia europea di Horizon 2020 per la parità di genere è assolutamente centrale questo obiettivo. Ma come si può introdurre la dimensione di genere nei contenuti dell'innovazione scientifica? Come si può ridefinire una nuova scienza tenendo conto del genere? Londa Schiebinger è l'esperta mondiale di questo potente nuovo approccio alla produzione di scienza e di conoscenza. Dalle macchine progettate pensando agli uomini come la norma e alle donne come l'eccezione, ai farmaci a sesso unico, dagli algoritmi di machine learning alla human-robot interaction, sono molti i danni del pregiudizio di genere nella ricerca e nell'innovazione. L'approccio va rovesciato. L'innovazione di genere arricchisce la scienza e apre nuovi orizzonti. Vediamo come. Invito Londa Schiebinger a salire qui sul palco. No, di qua, di qua. Oh, it's fine. Thank you.
Hello. Oh, yes. It's a great pleasure to be here today. It's just wonderful. Padua is a beautiful city, and I've been enjoying it, and the many people I've been meeting very much. So I'm going to be very American and start with a video. This is particularly about, we produce this for industry. It's about product design, but it will ease us into the artificial intelligence and the other topics, robotics.
So, you're growing your business and making the world a better place. Well, that's just great. But hold on a second. What if you were overlooking up to half of your potential customers? Don't be too hard on yourself. Even the most beautiful unicorns do this. When Apple released its health app, HealthKit, in 2014, it buzzed with all kinds of attractive metrics, recording blood pressure, daily steps and calories, blood alcohol content, of course, body fat percentage, respiratory rate, even mineral consumption.
But it left out women's menstrual cycles. Apple missed half of its potential market share right out of the gate. Apple corrected this problem and updated the app a year later, but what was the cost in terms of profit, poor publicity, and team morale?
What if your company is designing a biometric wearable to detect early signs of heart disease? Great idea. But recognizing that men and women have different patterns of heart disease will make the product work for everyone and potentially save more lives, you digital hero, you.
Or let's consider gaming. EA Sports only recently decided to include women's soccer players and teams in its blockbuster FIFA 16. Soccer is among the most popular women's sports globally, with more than 1.5 million female players in the US alone. By appealing to women, EA Sports has massively expanded its customer base, just like that.
What about hardware safety? Take automobiles, for example. All this talk about self-driving cars, and we can't even get the damn seatbelt right. Conventional seatbelts don't fit pregnant women properly, and motor vehicle crashes are a leading cause of fetal death. Gendered innovations have led to the development of pregnant crash test dummies that enhance safety in automobile design, finally keeping us all, even the smallest among us, safe.
Bottom line, products that incorporate the smartest aspects of gender and meet the needs of diverse user groups can open new markets and enhance global competitiveness.
This is low-hanging fruit. And to learn more about how innovators have already begun capitalizing, visit our website's list of case studies.
Today we're going to talk about gendered innovations. This video is on the website. You can show it to classes, you can show it to anyone where it would be helpful. And gendered innovations, as Silvana was saying, was created through a large international collaboration between scientists and engineers and gender experts, also some legal people, humanists, social scientists. And we started out with the European Commission, the National Science Foundation, and Stanford University. We've expanded also, as Silvana said, into South Korea, into South Africa, and Japan. And Gendered Innovations has brought together over now 120 basic scientists and gender experts in various collaborative workshops. And new policy has been implemented in the European Commission, in the United States, and in Canada. And we've also expanded into Silicon Valley. Stanford is located about 20 minutes from Apple and from Facebook, And we attempt to influence those companies. We made this video for those companies so that they can see that everything they create should be working for everyone. Innovation is about integrating sex and gender analysis into the design of research. The operative question is, how can we harness the creative power of sex and gender analysis for discovery? Does considering gender add a valuable dimension to the work? Does it take research in new directions? So before I get started, I want to give a bit of background. Governments and universities in the United States and Europe have taken 3 strategic approaches to gender equality over the past several decades. The first I like to call Fix the Numbers of Women, which focuses on bringing more women into science. But that's not enough. We need to also fix the institutions. This promotes gender equality in careers through structural change in research organizations. And we've had a lot of action at the European level there since about 2000. And the newest one is Fix the Knowledge, or Gendered Innovations, which stimulates excellence in science and technology by integrating sex and gender analysis into research. Now, we scholars analyze things into different buckets, like these 3 fixes, but we know that all 3 of those work together, and we need to do all 3 of those things. And we have some evidence from the field of medicine that shows that if there is more diversity on the research team, there's more likelihood that people will do sex and gender analysis, or vice versa. We don't know the directionality, but we do know that there is an important correlation. So my talk today is going to focus on fixing the knowledge. It's the newest area, and it's what gendered innovations is all about. And I hope to leave a few minutes at the end for your questions. So if you have questions, you can be thinking about what those might be. So now let's dive in. So I don't have the slide for this particular example, but I will explain it. So Google Translate defaults to the masculine, to he said, instead of correctly saying Londa Schiebinger, she said. So why is this the case? On the World Wide Web, in the English language, he said appears 4 times more often than she said. It peaked in 1968 and then dropped to a ratio of 2 to 1 in 2000. So in that period from 1968 to 2000, we had the women's movement, we had a huge cultural revolution which brought more equality to the English language. But with one algorithm, Google wiped out this cultural revolution, and it defaults to he. And then keep in mind that when Google translates something about a woman, an active woman, as he, it's now adding he's to the internet and makes it more likely that a program will choose he. So it not only perpetuates the bias, it also amplifies the bias, which is very important. So what's the fix? Because gendered innovations is focused on solutions. The fix, a couple of years ago, we invited Google to one of these gendered innovations workshops, and they listened for about 20 minutes. They thought maybe I was from a different planet, but they listened for 20 minutes, they got it, and they said, oh, we can fix that. So fixing is great, but constantly retrofitting for women is not the best road forward. I had to ask myself, how is it that the Google engineers, many of whom are educated at Stanford, how did they get out of my university and make such a simple mistake? What are we at Stanford University doing wrong? Well, for one thing, we have a lot of gender studies, but over in my part of the university, over in the humanities and the social sciences, and not right in engineering. So we are now trying to fix that. We are adding information about gender issues, about different social issues directly to the engineering curriculum, so that in every course where it would be important, it will be included. So some products can be fixed, But what if Apple, Google, and other companies started product development research by incorporating gender analysis? What innovative new technologies, softwares, and systems could be conceived? So this point, I want to point out and emphasize again that this unconscious gender bias from the past, if we just let it run and don't do something, doing nothing means that we allow that bias to be amplified into the future. So it turns out that even though Google wanted to fix the problem, they haven't been able to. It's very complicated, and I know all the reasons why they can't fix it. And sometimes it's harder to fix things once you've set a basic platform. That's why for gendered innovations, we want people to think about the design of research at the very beginning. We humans can intervene in these automated processes, in machine learning, and so on and so forth, to create an equal society. So now there are many examples like this one. There are now many examples like this Google Translate. It was a student of mine who discovered this Google Translate issue in 2012, and there are now many, many examples like this, and there are many fixes. So let me just run through the examples because they're pretty interesting. So in Google Search, if you open Google Search and you're searching for a well-paid job, men are 5 times more likely than women to be offered ads for high-paying jobs. So why is that? Again, it's the problem with the data. Any machine or human, if they look at the data, can see that men are systematically paid more than women. Google Search wants to get the right ad to the right person. So by choosing men, the machine thinks that's reasonable, that it will have gotten the ad to the correct person. So that's one example. Another example is word embedding. This is very interesting. We do a lot with natural language processing to see patterns in the English language. And when you look at these patterns, it's the machine sees the association between words in vector space. So it sees which words are close to each other and which words are associated. So the machine sees easily that man is highly associated with computer programmer, and that woman is highly associated with homemaker. Now, one of my colleagues at Stanford, James Zoe, they have a beautiful solution to this, which debiases this particular algorithm, and they can pull out the sexist associations in the English language while leaving the other words in their proper space so that we still have a language. It's a very, very cool application. Now let's look at a couple of examples in medicine. There are algorithms now that can detect skin cancer. So this is image recognition. People say that the machine is more accurate diagnosing skin cancer than humans are. And that's great. So one group at Stanford created that algorithm, but another group at Stanford is saying, well, wait a minute. Your data contains mostly white people. And so we know that this algorithm works very well for light skin, but does it work for dark skin? We just don't know. And we know that white people get skin cancers more often than people with darker skin, but we have to make sure that the algorithm is working for everyone because everyone is susceptible to skin cancer. There's another nice example from medicine, and this is predictive models in genetic medicine, so GWAS. And again, the problem with this algorithm is that 80% of the participants in it are European Americans, so people of European origins. And again, we don't know if the algorithm works for African Americans, and in fact, this person at Stanford, Popejoy, has found that African Americans are more likely to be diagnosed with the terrible kinds of heart disease, which they would be very upset if they received that diagnosis, and it may not be correct because, again, they are not represented well in the data. So we always are looking for solutions. Gendered innovation, what we do is we have these workshops which are interdisciplinary teams of computer scientists, lawyers, political scientists. We all have to work together to be able to see the solution. Computer scientists have a very particular technical education, and they don't know how to understand and avoid the social problems. So we had a workshop on machine learning where we wanted to identify exactly where in the machine learning bias resides, whether it's in the data, which it very often is, in the predictive models, or the algorithms. And then we mapped solutions, and then we discussed who should be involved in making the decisions about what is fair, what is equal. So I have just told you that the algorithms pick up human biases, and if we don't do anything, we will relive the 1950s over and over again. But then who should make the decisions about what the algorithm should do? Should it be the computer scientists? If we want it to be the computer scientists, we have to revise their education and incorporate social science into computer science. Should it be ethics teams? They usually come too far at the end of the process. Or should it be government oversight committees? And there's a lot of discussion about that now. So you can see some of our results from this workshop. We did a comment in Nature in July, which was very influential, and you can also go to our case study on the website. So I want to take one last example from AI before I before I go to robotics, and this is an example in computer vision, which was one of the examples we highlighted in our Nature comment. And I call this the bride problem. These are two images of brides, one here from North America and one from North India. Now, in computer vision, someone labels, the machine labels what they are, so that if you're typing in images of brides, the right image will pop up for you. I'm sure you've all used the image search. So these labelers labeled this image of the woman in white, the US bride, as bride, correctly, as dress, as woman, as wedding. But they label the Indian bride as performance art, as red, as costume. So the algorithm isn't understanding the cultural differences between cultures. So why is that? Computer vision uses ImageNet as its database. And ImageNet, interestingly, in ImageNet, which is thousands, it's many, many, many images, 45% of, it's 14 million images, 45% of those are from the United States, even though the US makes up 4% of the world population. So an asymmetry in the data. The data from China and India combined is only 3% in this data set, even though they make up 36% of the population. So we need to correct our data sets with appropriate geodiversity. Now let's shift gears to robots. We also held a workshop, I can't go there because we don't have the internet. So we also have our second big project this year is work on robotics. And we held a workshop at Stanford in January with roboticists and with historians and social scientists. And we wanted to know about gendering the robots. You can be sure that the robots are coming. I'm surprised we don't have one here today. They're coming to help in hospitals. They're coming to help in elderly care facilities. There aren't enough young people to take care of the elderly people in our society, and it's hoped that assistive technologies embodied in robots can help do that. They also help in schools with autistic children. So one question is, how are we going to gender these robots? So why do people feel the need to attribute gender to robots? We gender everything, right? We need to know, is it a boy, is it a girl? Gender is a very important social category for us because it's a power category, and therefore we insist upon gendering things. So, and we wanted to know, is gender domain specific? Is a woman's voice ideal for a dating app? Is a man's voice ideal for a math app? And we wanted to know what genders a robot. So our challenge to roboticists, to designers of robots, is to understand how gender becomes embodied in robots and to design robots that promote social equality. So robots are designed in a world alive with gender norms, gender identities, and gender relations. Humans, whether designers or users, tend to gender machines because, as I said, gender is a primary social category. And many robot designers and specialists in human-robot interaction argue that the human tendency to project human social cues or gender onto artificial intelligence may help users engage more effectively with the robots. For example, humans expect a nurse to be a woman. I don't know what it is here in Italy, but in the United States, 90% of nurses are women. So does that mean that a nursing robot should be female so that it meets users' expectations? Will humans take their medicine? Will they be more compliant? Will they follow the orders of the female nursing robot? Will they do their exercises? Will they comply with the robot's instructions? But there's a danger there. As soon as users assign gender to a machine, stereotypes follow. Similar to what I said about machine learning, the danger is that gendering robots may reinforce gender inequalities by hardening current stereotypes into the design of machines. So if we think that we have gender bias in AI, which are just programs, it's I think, much more difficult if we embody stereotypes in the robots themselves, because now you've built hardware, it's very expensive, and it will be hard to change. So we want to think very carefully, if we challenge stereotypes, if we make the nursing robot male, does this make it easier for men to actually enter the profession of nursing? So designing stereotypes may amplify those stereotypes in the future, just like it would in the artificial intelligence. So now let's look at what genders a robot. How would you read this robot? What are the social cues in this robot? This is Pepper, designed by SoftBank in Japan. And first, let's look at color. What does color have to do with it? There's one human-robot interaction group that put a black hat on this robot, and everyone considered it a male, because a black hat is obviously a male thing. They put on pink earmuffs, and okay, now suddenly it's very gendered, it's very much a female. So color is important. Now, people point out that almost all robots are white plastic. So this leaves out many other populations in the world, people with darker skin, people who look different and aren't just white. So, and interestingly, if there is no clear gendering, we default to calling the robot a he, because in many languages, the word for robot is masculine. Not in English, it would be an it, but we still often call it a he. So that's one thing, the color. Now, voices. This robot will have a voice, and voices are full of cultural information. The pitch of the voice indicates whether it's a male, if it's a low pitch, or a female, if it's a higher pitch. And lower voices in our culture carry more authority. For example, you'll remember Margaret Thatcher, who was the first woman prime minister in the UK. She went to the National Theatre in London to have voice training because she wanted to lower her voice to have more authority in the culture. So the choice of voice, so in the robot, you can usually choose a voice. Many robots use a childish voice, a child's voice. That's a good choice because number one, it's very hard to hear the gender, harder to hear the gender in a child's voice. And number two, children's voices are non-threatening. So if it is a robot for elderly people, having it be childish would be a way to make it friendlier. They also often shape the face, make a very small chin, so that it looks more like a baby's face. So it's, again, a childish kind of thing. So now the name. They've named this robot Pepper. Do you have associations with the name Pepper? Do you think of Pepper? Oh, you do? Sergeant Pepper. Yes, you could have Sergeant Pepper. My association with Pepper is Gwyneth Paltrow, who was the assistant in the Iron Man movies. Because otherwise, Pepper, it's more like a dog's name, right? I mean, it's not a name we use a lot. It's not a common Western name. So I think they did a pretty good job naming it Pepper, because that's pretty gender neutral. But now let's look at the anatomy. Pepper's anatomy I find extremely confusing. With the absence of hair, the robot looks kind of boyish, but it has this very cinched waist, right? And this flowing skirt. Now we have to remember that in Japan, men traditionally wear skirts, right? The samurais have big skirts on, so we shouldn't rule out that that could be a masculine characteristic, but I think the anatomy here, the shape of the robot, seems very feminine. And then personality. The roboticists design in a character for the robot. And I haven't studied Pepper's personality, so I'll talk about Siri. You have the iPhone and the voice Siri. So Apple was highly criticized when they came out with an assistant being a female, because it's just like, okay, we know that administrative assistants, secretaries are female, and we saw that as hardening the stereotype. So Apple immediately put out some male voices, and then they realized they only had American English, so they did British English, Australian English, and now they realize they have nothing for India, so they have done Hinglish. I think it's still coming. But this means that they still don't have accents for Jamaica and other places where it's hard. So personality is one thing. Then Siri is very often harassed. People say nasty things to Siri. They don't thank Siri. She's highly harassed. And Apple used to just let this go, but now they have programmed Siri to defend herself a little bit without upsetting their customers. And we have to remember that there is this overlap. This is a sloshing back and forth between how we treat robots and how we treat humans. So companies should not allow their robots to be harassed without some kind of appropriate response. So we have to remember all of these things when we're talking about robots. Now, I was very happy to find this set of robots, Milo, who only come as males, but it's the only example I found of customizable skin color. These are assistants for autism. Autism is primarily a problem for boys, at least in the United States, but many, many girls also have autism, so I would encourage this company to customize so that you could choose a boy or a girl. Then I really like this Japanese robot, which is for hospitals. It's for lifting patients, which is a very common problem. And you can see that they stepped out of the social relations completely. They made it a giant teddy bear. What a nice solution, right? We don't have to gender it male or female. We can just have it be in the animal world. So again, the challenge to roboticists is to understand how gender is embodied in robots, and importantly, to design robots to promote social equality. With care and through collaboration between humanists, social scientists, and roboticists, I think we can intervene in the design of robots to create a virtuous design cycle, that is to say, to create robots which will promote social equality. Now, I could give you many examples from my website. I wanted to turn a moment to policy, and this is all on the website, so I'm just going to mention a few things quickly, and then I hope we have a few moments for discussion. So there are 4 things that are very important if we want researchers to consider sex and gender, to integrate it into their research so we get the research right. Doing research wrong costs lives and money, and we really need to get research right because that makes products and knowledge that is safe and helpful to everyone. So there are 4 policy things that we need to keep in mind. One is granting agencies. As you know, the European Commission since 2014 has asked that all PIs, all researchers, integrate sex and gender analysis into their research, or you're not as likely to get the funding. So it's public money, and the public money should be expended to serve everyone equally. I should say that the Germans are putting this policy in place in 2019 in January, as are the French, and I would encourage the Italian funders also to take this step. So that's number 1. Number 2, we also need to make sure that peer-reviewed journals ask for sophisticated sex and gender analysis when accepting articles for publication. So with the funding agencies, we have a control at the beginning of the scientific process, and with the journals, we have a control at the end. And some very high-profile journals like Lancet and Nature have such policies. We have policies for medicine, health and medicine, but none in computer science yet. So if any of you are members of editorial boards in computer science or engineering, I'd love to talk to you. Then the third thing we need to do is integrate this knowledge into the university curriculum. So as I said, we have a lot of this knowledge in gender studies, in history, in literature, but we need more in engineering, computer science, and robotics. And then the 4th aspect is industry. Products and systems that incorporate the smartest aspects of gender can open new markets. Products that meet the needs of complex and diverse users can enhance global competitiveness and sustainability. So there's much that we need to do, but I think we're beginning to understand how to incorporate sex and gender into research and what a difference it can make. And finally, if you are interested in this topic, you can go to, I send out a newsletter about once a month, and only I send it. There's no spam on this system. And if you want to be updated on these particular topics, please go to the website and sign yourself up. Thank you.
Hello, good afternoon. Thanks a lot for your work, and I'm agree, of course, about your vision of fighting gender issue, but I'm not on your side when you are genderizing things. I'm a technologist.
You're what?
I'm a technologist, I'm a maker, and I create things that are things, and I don't want to call a thing a she or a he if it's a hit. I want to stay human with human and human with things, and I don't consider Siri as a she. But of course, there are some problem in this. For example, I've seen a Vice documentary about sex dolls.
Oh, yeah.
That can be embedded, of course, with technology. And also if these artifacts are things, can be very tricky to understand, is it gendering or not? So where is the boundary between human and things?
Yes, well, I think this is the goal. This is the goal, to make it. Yes, but I think first we have to wipe out gender in society. We have such strong gender norms in society. So I completely agree with you. The problem is that you can't control how the users consider your technology. And then very often there's just, you know, defaults where people, I hope you're really thinking about this, but there's so many defaults. I just bought a Tesla, a beautiful electric car, a Tesla, created by Elon Musk, and it doesn't fit me. I was so disappointed, so I got in, and the sun is shining over here, so I take my visor to shield the sun, and it hits the headrest. So for me, if I want to shield my eyes and have a safer time driving, I have to push the seat back while I'm driving, I have to put the headrest over while I'm driving, I have to put the seat forward again so I can reach the gas pedal. So very often there are these defaults. Tesla has not heard from me yet. I just got this car. And then I wonder, okay, that's what I see. Are there other safety things in the car which aren't built for a very tall and powerful woman, right? So as you know, if you think about don't fall into the default, that's a great first step. And then I would very much like to keep robots separate, but I'm afraid they're becoming social actors, and I don't know how to stop that.
Thank you, Londa, for such a wonderful talk. Very useful. We're not there yet to what you're doing in Padova. We're trying to. Just a comment on the previous question. I heard a very interesting talk in Amsterdam last week. It was a conference on STEM and gender. And there was this intervention about Siri, and the fact that Siri, talking about her becoming a social actor, is the object of very explicit erotic or sexual requests from male users. And that is...
And possibly from females.
How to deal with that. So now they're trying to program her own answers in a neutral way, but still, the fact that she has a kind, soft woman's voice will induce people to, use her as a, sexual robot or something like that. So that's how things work in the world now. My question is more practical, because we here are we are thinking of redesigning the curricula of the sciences so as they include gender. But that's not easy. We do not have a model here. And since you spoke about engineering, I was wondering whether there's something already published on the web about what you're doing in Stanford in order to include teaching, actually, I guess, some kind of pedagogical awareness within the courses in engineering, so that we can actually start from some good practice. Thank you.
Yes, well, I wish we did have something on the web, and I wish that we were already to what I see as the end point, but we're only at the beginning point. So our engineering school has one course, which is not required, on gender and all kinds of intersectionality issues, which students can take. It's very popular, but it certainly does, our engineering school is huge. It only receives 50, 60 students a year and not hundreds of students a year. So that's not really working yet. And then for computer science, the computer scientists recognize all these problems I talked about and are very concerned. And they have created a separate course, which is required of all computer scientists, but it's a separate course again on ethics. It's a very broad, it includes gender and all kinds of things. I think that the social issues should be included right alongside whatever algorithm you're talking about, whatever technical issue you're dealing with. Let's talk about, it takes maybe 10 minutes, you know, talk about the social issues in respect to that particular thing you're designing. So that is what I see as the end point, and I hope that we will have more of these ethics courses in computer science are completely new. The first one started at MIT Harvard last year. Stanford's catching up and having one this year. So I hope we can now move even further. So no, sorry, not yet. Yes?
Yes, last little question. First of all, machine learning is different from artificial intelligence, but so it's better to call the algorithms of machine learning that are biased. But the problem, in my opinion, is not to develop this knowledge, to disseminate this knowledge that the algorithms are biased, but also to write some guidelines for engineering, for software developer of algorithms based on machine learning. Since now it is sure that they don't work well from a social point of view.
Right. So I can't show it to you, but we are developing such a process, an instrument. So Stanford is founding a human-centered AI institute. It will be announced in March. And they are very interested in the human part to be added to the technological part. And we're developing a process by which, so we've taken the process of machine learning, and then for every step, we're showing the resources. So the articles that are available for issues with that step. So for data collection, for instance, there are 3 instruments nationally now. One is called data nutrition. So they want it, it's like food labels. They want to know what's in your data. So they want to know who is represented, and so you can control your data in many instances. When you can't control your data, then you come to the algorithms, and we're loading up all of these interesting debiasing programs. So the debiasing programs tend to be focused on a particular problem, but some can be generalized. And what we want to do is just have a place that everybody can go, can load up more, and can also see what's been done.
Thank you. Grazie a tutti. Thank you.